moment you press enter before the first word appears on your screen, something genuinely strange happens inside that machine. You asked a question. An answer came back. It felt like the machine went somewhere, found the truth, and delivered it. Here is the uncomfortable part. It didn't look anything up. Nothing was searched. No database of facts was opened. No library was consulted. The machine that answered you does not contain a single stored sentence. And yet it wrote you a fluent, confident, usually correct answer in seconds. Today you're going to understand exactly how. Not the cartoon version. The real mechanism, step by step, in plain language. This matters because you already trust these systems. You ask them about your health, your money, your work, your homework. Millions of people now take the answer, act on it, and never once ask where that answer actually came from. So let's start with the claim that sounds impossible but is true. When an AI answers you, it is doing one thing over and over, guessing the next word. That's the entire trick. Predict one word, add it, predict the next, add it, thousands of times per answer. Your first reaction should be, that cannot possibly work. Guessing words shouldn't produce working code, legal summaries, and medical explanations. Your instinct is right. And that's what makes the real answer so interesting. Because to guess the next word the machine had to learn something deeper. The shape of meaning itself. Quick honesty note while we're here, I'm simplifying a fast-moving field and the labs themselves don't understand every detail. What follows is the accurate big picture, the one researchers agree on, minus the mathematics you don't need. By the end, you'll know why it writes so well, why it sometimes lies with total confidence, and when to trust it. And once you see the mechanism, you will never read an AI answer the same way again. Here's our route. Stop 1. How your words become numbers. Because this machine, strange as it sounds, cannot read at all. Stop 2. How guessing gets scary good, and what training on the internet really did to this thing. Stop 3. The attention trick that lets it juggle your whole conversation at once without losing the thread. Stop 4. Hallucination. The moment the machine invents a fact, a citation, a court case that never existed, 4 stops, 18 minutes, one mechanism hiding underneath every single answer you've ever received. So let's go back to that moment. You've just pressed enter. Your question leaves the keyboard. Follow it with me. First problem. Computers don't process words. They process numbers. So your sentence is immediately chopped into pieces called tokens. A token is roughly a word or a chunk of one. A long word might split into 2 or 3 pieces. Each piece then gets swapped for an ID number, picked from a fixed menu of tens of thousands of tokens. From this point on, the machine never sees your words again, only numbers. But a raw ID is meaningless on its own. Token number 402 says nothing about cats, taxes, or heartbreak. So the model expands every token into a long list of numbers, thousands of them. This list is called an embedding. Here's the beautiful part. Those numbers work like coordinates. They give every token a location in a giant space of meaning. Words used in similar ways end up parked near each other. Dog sits close to puppy. Far from spreadsheet. Inside this machine, meaning is literally geometry, distance and direction between points. And directions carry ideas. Famously, take the point for king, subtract man, add woman, and you land almost exactly on queen. Nobody programmed that. The relationship between royalty and gender emerged as a direction in space learned from reading. The same happens for tenses, capital cities, tone, grammar, even rhyme. Thousands of concepts, each a direction. This meaning map wasn't designed by hand. It assembled itself as a side effect of one brutal training exercise, which brings us to stop 2, the strangest school any mind has ever attended. During training, the system is shown text from books, articles, code, forums, trillions of words worth of human writing. The exercise is always identical. Hide the next word, make the machine guess it, score the guess, adjust, repeat, get it wrong, and millions of internal dials nudge a tiny bit toward the answer. Then the next word, forever. Those dials are the model's parameters. Modern systems have billions of them tuned by this one repetitive game. At first, the guesses are garbage, random letters, then plausible words, then grammar clicks, then facts start landing. Because here is the trap hidden in the game. To guess words truly well, you must understand what they describe. To finish a physics sentence, you need physics. To finish a joke, timing. To finish a diagnosis, medicine. So the pressure of one dumb exercise forced something that looks a lot like understanding into those billions of dials. Is it real understanding? Researchers argue about the word. What's measurable is this. The predictions became astonishingly good. Good enough that when training ended, the same trick could run in reverse. Not scoring guesses, but generating them for you. And that's the machine you're talking to. A frozen snapshot of that training sitting behind a chat box. Frozen matters, nothing you type retrains it. Close the chat and it remembers nothing. Tomorrow it is exactly the same machine. So how does a frozen guessing machine handle your specific, brand new, never seen before question? That's stop 3. Your question arrives as tokens. The model's only job, produce a probability for every possible next token, not one answer. A ranked list. Maybe the word the at 18%, A at 11, thousands of tokens trailing behind. Then it picks one. Usually a top candidate, but not always the single most likely. A dice roll decides. That controlled randomness is called temperature, and it's why the same question gives you a different answer every time you ask. The chosen token is glued onto the text, and now everything runs again, from the top, for the next one. One token per cycle. Your 3-paragraph answer? Hundreds of separate predictions, each one built on all the ones before. Read that again because it changes everything. The model never plans the whole answer. It cannot see its own ending. It's writing the way you sometimes speak, launching into a sentence, trusting the ending will arrive on time. Now, the obvious objection. If it's guessing word by word, how does it stay on topic across a whole essay? Because before every single prediction, it rereads everything. Your question, its own words so far, all of it, every time. That constant rereading is powered by the invention that made modern AI possible. It is called attention. Attention lets every token look back at every other token and ask, how relevant are you to me right now? When the model writes the word it, attention binds that little word to the exact thing it refers to paragraphs back. Dozens of these attention searchlights run at once. One tracks grammar. One tracks names. One tracks your tone. Stack that process in dozens of layers and simple word matching turns into something that behaves like comprehension. This whole reread has a limit, though. The context window. The model's entire working memory for your conversation. Talk long enough and your earliest messages fall outside the window. To the model, they simply stop existing. That's why it forgets your instructions from an hour ago. Nothing broke. The paper just ran off the desk. Notice what's missing from this entire machine. There is no fact checker, no truth meter, no little librarian inside. Probability is the only currency. Sounds right and is right are the same thing from where it stands. Most of the time, that's fine, because the truth genuinely is the most statistically likely continuation of a question. The most probable completion of the capital of France is the right answer. Statistics and truth agree. But keep that machinery in mind because in a few minutes you'll watch it fail in a very specific way. First, one more piece. How a plain guessing engine became the helpful assistant you actually talk to. Because raw models are wild. Ask one a question and it might just continue your question, or write 10 more. Predicting text means imitating text, and the internet contains far more questions, arguments, and nonsense than clean answers. So after training, humans step in. They rate the model's attempts, helpful, harmful, honest, useless, thousands of judgments. Those ratings retune the dials one more time, teaching it to prefer the answers people actually want. That's the assistant you know, a predictor, sanded and polished into a conversational shape by human feedback. Every answer you've ever received is that pipeline. Tokens, meaning space, attention, probabilities, dice roll, polish in milliseconds. Now the question underneath everything, if it's statistics, why does talking to it feel like talking to a mind? Part 1, scale did strange things. As models grew, abilities appeared that nobody trained for and nobody predicted. Translation, arithmetic, writing code, passing exams, they emerged from word prediction at sufficient scale, like steam from heating water. Part 2, it learns from your chat, live, without changing a single dial. Show it 2 examples. It catches the pattern, that's called in-context learning, and it happens purely inside the attention beams, inside your context window, inside one conversation. Remember, the dials stay frozen. The window is where the learning happens. Part 3, when it thinks step by step, it's really writing its way to the answer, using its own output as scaffolding. Each written step becomes new context for the next prediction. Reasoning for this machine is thinking out loud, literally. So it feels like a mind because it's a mirror of millions of minds, compressed into geometry and probabilities. But mirrors have edges, and you should know exactly where they are before you lean on one. Edge 1, it has never touched the world. It knows water is wet the way you know Napoleon was short, hearsay. Edge 2, numbers. It reads digits as tokens, not quantities, which is why long arithmetic can wobble embarrassingly. Edge 3, time. Training ended on a specific date. Everything after that date simply isn't in the dials. Ask about yesterday's news, and a pure model must either refuse or do the dangerous thing. Guess plausibly. Modern assistants patch these edges with tools. They can call a search engine, run a calculator, execute code. When it searches, the results are pasted into the context window, and prediction continues, now anchored to fresh text. Understand this. The engine never changed. It just got handed better ingredients. And that distinction, engine versus ingredients, is the key to the final stop. The lie machine inside the answer machine. Before we go there, lock in the frame. This machine is an interpolation engine over everything humans have written. Between known points, it glides brilliantly. That's why remixing, summarizing, translating, and explaining feel effortless to it. Far outside the map, where no human text ever went, the fabric sags. And the machine doesn't feel itself falling. There's no alarm for I don't know this. Low confidence just means flatter probabilities and the dice still roll. Hold that image. The dice roll on a flat leaderboard. That is where every AI lie is born. Hallucination. The industry's word for the moment an AI states a fiction with the calm confidence of a textbook. Lawyers have filed real court briefs citing cases that never existed. Students have chased papers no one ever wrote. The fakes are perfect in format. Real-sounding names, plausible dates, correct citation style. Only the existence is missing. Now you know enough to see why. The model wasn't lying. It was doing its job perfectly. Asked for a citation, the most probable continuation is something citation-shaped. So that is exactly what it built. It filled the shape with the likeliest ingredients. A real-sounding author, a plausible year, a journal that fits. Truth was never on the ingredient list. Probability was the whole recipe. The same failure hides in summaries that invent a detail, biographies that merge two people, statistics rounded into existence. Labs attack this constantly. Cleaner training data, rewards for honesty, built-in retrieval, teaching models to admit uncertainty. Each generation hallucinates less. But the failure can't fully vanish because it isn't a bug bolted onto the system. It is the system. The same probabilistic guessing that writes your emails is what invents the fake court case. Kill the guessing and you kill the writing. Creativity and confabulation are the same muscle on this machine, so the fix, for now, lives on your side of the screen. Which brings us to the trust framework. So when is it safe to trust? Here's the honest framework. The one power users actually run in their heads. High trust, explaining established concepts, rewriting your text, brainstorming, coding patterns it's seen 1,000,000 times. The map is dense there. Low trust, specific numbers, dates, quotes, citations, niche facts, anything recent, and anything about people who aren't famous. The rule of thumb: trust the shape of its thinking. Verify the atoms. Every name, number, and quote gets checked, and use its own machinery against the problem. Ask it to cite sources, then open them. Fakes die in one click. Ask the same question twice in fresh chats. Solid knowledge repeats. Hallucinations mutate between rolls of the dice. Give it your documents, your data, your context. Grounded text tames the dice better than any clever wording. And when the stakes are real, health, money, law, treat every answer as a well-read friend's opinion, not a verdict. None of this makes the technology weak. It makes it specific. Powerful at patterns, unreliable at atoms, honest about neither. Which leaves one final question, and it's the one you'll actually remember tomorrow. So what actually happened in that half second after you pressed enter? Now you can see all of it. Your words became tokens. Tokens became coordinates in a space built from everything we've ever written. Attention beams bound your question together, layer after layer, until its full meaning stood in that space. Then the leaderboard, the dice, one token, and again, hundreds of times, until the answer stood on your screen. No search, no library, no little mind, geometry, probability, and you. Keep this mental model, the world's most well-read autocomplete, holding a map of meaning, rolling dice at every word. Talk to it like that and everything improves. Give context, ask for its reasoning, check every atom, enjoy the glide. You're no longer the person who takes the answer on faith. You're the person who knows what's behind the curtain and uses it better because of that. That's the promise of this channel. Not magic explained away, but magic explained so you can finally use it properly. Next question you type, watch that first word appear. You'll see the dice land. If this rewired how you see AI, subscribe. Next up, why this genius machine can't count the letters in strawberry.